Okay, so this is the event that that you probably saw the banner for. So how to make a safety net for your LLM applications, and basically what we're going to be doing is learn the principles of safeguarding an LLM-based app against various types of risks, malicious prompts, and we're going to look at a few different tools. Two tools that NVIDIA are involved with, which is Garak and the NeMo guardrails, and also Deepchecks that you'll see. And just a bit about the speakers. So Chris, aside from anything formal we can say, I think Shir and I both have already learned a lot from. Hope to continue to learn more as we hopefully continue to collaborate. So Christopher is a senior manager of applied research at NVIDIA, and he's working on NeMo guardrails, I think is what he's most well known for. He's also involved in some of the other things that you'll see here today. And he has a PhD in computational linguistics from the University of Toronto, where it connects a really interesting field of how children learn language. And NVIDIA has the mandate to bring trustworthy language models to large enterprises. So this is Chris. Shir, my co-founder, CTO at Deepchecks, has been working with me for a long time, also before Deepchecks, and is graduated with Talpiot Excellence, and definitely an expert in this space of LLM evaluation, LLM safety, and you can probably see her on many other events that are either online or physical. So a bit about the agenda. So we're going to have short talks by both Shir and by Chris, intro to LLM evaluation by Shir, then we'll move over to Chris and have talk about the open sources for LLM application safety that I mentioned earlier. Then we're going to have a couple of demos and kind of talk about how they all connect with each other. And during this time, I mentioned again, feel free to ask questions at any point. I'll hand over the mic now to Shir. As we're starting with the first slides, etc. So I'm gonna send the first poll. So just 1 second here as I stop sharing. So the first poll we'll be launching is asking about the stage of the current LLM application. You should probably see it. What's the current development stage of your LLM application? Conceptualization and design, development and testing, production and deployment, or optimization and scaling. So we'll let that run for a bit. Feel free to take to do the first slide or two, and then I'll rudely cut you off in a second. Yeah, I think that's it.
Sure, sounds great, and happy to be here. Okay, so I'll start and stay kind of tense until you tell me when you want to show the poll results. So we're really going to talk about a bit about, like, in general, looking at your LLM app and does it perform the way you want, with an emphasis of the safety net areas. So yeah, let's just jump in. So this is a slide that doesn't really need explanation or any time, because all of us, and especially those that are here, already know that LLM applications are really everywhere you look. And this one shows a few of the interesting or nice and also quite recent examples of where and how they go wrong. And if we look at a few of these examples, we can see that many of the ones here have to do with things like basically them explaining things that aren't necessarily that accurate, like how you can train 8 days a week, or how you can how long do you need to stare at the sun for best health, and also things like, you know, a chatbot promising a certain price and then the other airline needing to actually pay it, and so forth. And that does give a bit of a kind of intro. By the way, do you hear me fine? Because I see, like, yeah, all's good, cool. So that does give an intro about when you look at evaluation or at checking that that the LLM apps do what we do. There are actually two somewhat related but not directly identical criteria. And what I'm going to do is, first of all, kind of give the intro and overall approach to both of them, and then we're going to dive in a bit deeper into the safety. So the two areas are both the topic of making sure that it doesn't do something that we don't want it to do, like give any PII or give any internal company information or talk in a way that it shouldn't. This is more like on the kind of safety area. However, the quality topic is also quite related, because if it gives misleading information or if it gives internal company information, they're both kind of harming the same aspects. So these are the two aspects we're going to talk about, and the two things that that we recommend, or then like the action items that you can do is, one, when you build and try to improve and kind of try to mitigate all of the different faults. So that's like the best version is basically try to see what you can fix, whether it's with your prompts or with your or with changing the base model you're using, or with adding any additional parsing around it and so forth. And the second is also adding active guardrails in order to mitigate the behaviors which are still there when it's in production.
Okay, just 1 second. We'll do a small break to share the results of the first poll. So we can see here 26% of the folks here in conceptualization and design, development and testing is 35%, and production and deployment is in 32%. Optimization and scaling is just at 6%. I think what's interesting here is I think production and deployment is a bit higher than I see in some other surveys that we do. Optimization and scaling is a bit lower. So I think it's definitely something of definition, but I think the difference is if you have like the first few productions, or if you already have quite a few. Anyway, really interesting, and it's always good to know the characteristics, and hope you enjoy in the meantime, and that you find it relevant in the phase that you're at.
So one emphasis that what we're going to talk about is, like, if you search for LM evaluation, you'll see lots of benchmark and comparison between all of the models and so forth. I do want to differentiate between evaluating whether it's for safety or for quality your specific LLM application, which can be of various types, like Q&A, summarization, content generation, and so forth, or evaluating the foundational model. Of course, that foundational model is part of your application. However, it's not the only part, and many times some of the things will be either new problems added, or some of the problems actually blocked within your application. So that's the top context we're going to drill into. And the notion of efficient evaluation is really relevant throughout the life cycle of your development. So talking about like the 3 different phases that most of you voted in, from like initial experimentation to production. So it's relevant really to combine this as part of your process, whether you're still in the initial iterations or your model's already in production. And then anyway, this is a cycle, right? So once you have a model or a version in production, you're likely either developing your next one or improving it and so forth. And the idea is that once you have it set in place, you can really work much more efficiently. So that was a bit of the intro, but now kind of taking a specific example and seeing how and where this meets us. So in the context of, let's say, a Q&A RAG application, there are a few additional phases, which, of course, on top of the model itself. So in this case, like, let's say we have a user asking a question about a medical use case, and maybe they're asking whether some info about their medical records or about some specific conditions. So just kind of an example of the different phases. So for the question, maybe we'll have either like detection of the intent of the user, because it may go into a different pipeline or a different prompt. So like the user's question may actually open new or different routes for the application itself. The retrieval phase, which is likely we want to bring the relevant documents within the whole all of the users' records, maybe do some like internal kind of prioritization with re-ranking, and the answer itself, which of course incorporates also 1 or more LLM calls, but potentially some additional output steps. Like formatting, maybe adding some additional logic, wrapping it, and so forth. So in the context of evaluation, what we look at is the end-to-end pipeline. So the kind of like what we care about initially is like obviously the different phases in the way also, but did it achieve the result, yes or no? However, when we actually want to inspect or improve, then these are the different places where it's likely that changes will actually have that effect. So the 2 key things that we look at when we want to build this is basically 2 areas. One is the metrics, or like what are we checking for, whether it's for quality or for safety, and we'll see that in a second. And the second is, what is the data set we're going to evaluate on? And these 2 things will actually lead us, like it's things that you'll also see in the demo. Like how do we construct, or how do we choose, or how do we build data sets in order to help us basically try to, in this case, like find different safety related problems, see if they're solved, see if we successfully mitigated them or not in a trial, in an attempt to, let's say, add guardrails and solve them. So this is like one example for building a data set that is specifically tuned for, let's say, safety areas. And for the metrics, it's also a bit of a combination. So we'll see that basically here. So before, the examples I showed of different ways where LLM applications go wrong. So it may be that they're hallucinating, right? Which is, we can say, maybe more of a quality related problem, or maybe they're not complying to the company guidelines. Like, for example, they're recommending a feature of a competitor instead of our feature when a user asks a question about how to use the product. And then there's areas, are they also potentially explicitly giving any things that we don't want them to, whether it's giving some private information of one of the users, bias, acting in a toxic manner, like if they were prompted for that way, or rather the user like tried for some reason to basically make them interact in a way that they're not supposed to. So a few examples for each of these metrics. So for the quality, and this is, okay, so it's basically a twofold. One thing is, what are we actually trying to check for? Like, what do we care about, right? So we care about the task being fulfilled, or it being in the right format, and so forth, and also various problems mitigated. And then we have the way of, what are the metrics we're actually checking for, right? So like company guidelines may now be actually no competitors mentioned, or privacy, making sure that there's no PII leaked in any manner, or hallucinations, or relevance, so making sure that the output is actually answering the user's question, or that it's actually based on the context that it was given, and so forth. So the idea, and something that we'll see here, is eventually what we really care about is some combination of all of these. So we want it to be both good and also not harmful. And also, it's a bit relevant, it's a bit dependent on the use case, right? So some cases where there's, for example, no PII involved, obviously that's not an issue. Or some cases, maybe we're very, very sensitive to, like, do we have external facing users, yes or no? That may be a good consideration. Do we even need to check for jailbreaks, for example? So the idea is that we really need to customize it to our use case. And also, our recommendation is to have an easy way to aggregate all of these metrics and then achieve an overall understanding of where are the places where it's good and where is it problematic, in order to be able to, whether it's compare between versions or investigate a specific problem. So the metrics themselves and how they find different types of problems, we'll see kind of in action a bit later. And now the second thing is, what do we run this evaluation on, right? So like, I built an LLM app. Cool, I know that I have a user asking questions, and then I have some of, let's say, their medical records being brought, and then an answer being formed. However, what do I want to check that this app works properly on? So also here, we split it a bit into two. One is evaluation for the purpose of, does it work properly in the context that it's supposed to? Like, for example, a user, in this case, asking about something medical, and maybe they might interact with the system in different languages, for example. So this is something that we would want evaluation data sets to have. And maybe it may ask different types of requests, right? So we would want it to make sure that it answers them properly. However, if these are the types of questions we get, then it's more likely that we will want, like, for example, to detect off topic and not respond. Okay, so it's also kind of making sure what are the areas in which we want it to work properly, and also to make sure that in other areas it doesn't. And there are also things that are related, like, not necessarily to what is the exact content, but also to some guidelines on what would be a good answer. So in this case, we have like two examples which have the exact same information. However, we'd probably want to give the top one a much higher score than the second one, just for clarity, usefulness, and so forth. So it's not always all black and white. It may also be like some preference of, for example, adhering to a certain format. So these were a few examples of like of how to build an evaluation data set in the context of what are the types of things we would want to have and to verify our quality on and verify that it gives essentially correct and accurate answers. However, not everything is, the world is not always all roses. And of course, there's various things that can happen, whether if intentionally or not. And these are a few examples of like, so here the focus is a bit more on the, let's say, safety area. I will say, like, bottom line, what we really recommend is to have two different kind of evaluation flows and then verify that both of them are proper. So for the safety areas, just a few examples of like problems in each of the phases. So in the user's question, it may be jailbreaks, but it may also be edge cases. We'll see in a second. In the retrieval phase, it may be things, again, that are just related to us not having enough data in the knowledge base, which is more of a quality issue, but also things like PII. And so just like the two examples of before, so the first one is like, these two are obviously really more kind of intended to check the boundaries of the LM app. Right, so it's not, it's less a issue here of wanting to verify that it's acting correctly, and rather to make sure that I would want it not to respond. So that's kind of the context of evaluation for safety and really mapping out what are the different types of problems and how do we detect them. And well, same also, whether it's for the question or for the answer. So if summing a bit up, the topics we discussed is that when we want to have a wholesome look at our LLM application, what we, maybe I'll put this slide. Cool. So we mentioned quality and safety and looking at how to evaluate whether it's to build a data set, think how we build a data set for each of them, and then also compare different behaviors or different data sets between different versions, and then also in production. So that's like kind of the context of building the baseline for it. And we're going, before we see it in practice, let's dive in a bit more into the areas of, okay, so these safety, how do we build a data set, and what are these metrics, and how do we check for them, and how do we mitigate them? And I'm happy to hand it over to Chris to talk about Garak and for safety and NeMo Guardrails as a Guardrails platform.
Thank you very much. Let's get this shared here. All right.
Just before you start, Chris, 1 second. So we got one question from anonymous attendee asking, should any benchmark available for your LM evaluation tool? There are so many tools available, hard to choose, specifically for JSON data. So I encourage you to wait for the demos, and I'm sure after the demo, then it'll be pretty, there'll be at least some visibility in it, and we can also definitely follow up and offline for any specific requests. I'll add my mail here for for that to make it kind of a bit easier.
All right, thanks. Okay, so as Philip said in the intro, I lead an applied research group at NVIDIA, and we work on safety and security for LLMs. So there's two projects that we manage within our group, and they have very complementary roles. One, we call Garak, is a tool for assessing security and safety in an LLM, in the model or in the system containing that. And on the other side, we have NeMo Guardrails, which is a toolkit that we have for adding protections into these systems. Now, the key thing about both of them, and Shir was making a really good point about this, is that they're really taking this application view, this system view of how we deploy and use these LLMs. There's a lot that we could build into the core model itself, but there's a lot that really matters at that application level. So we'll start with Garak. So if you're familiar with some of the more common tools in cybersecurity, tools like Nmap or Metasploit, Garak is kind of like Nmap and Metasploit for LLMs. Really, what you're going to do is you're going to take a model or a system, and we're gonna probe it with a whole bunch of possible attacks and see where it's vulnerable. So Garak contains a whole collection of different probes. We call them probes. These are individual attempts at a different attack. So some of these, we'll look at some of them. Some of them are going to be like jailbreak attempts. Some of these are going to be like training data replay attacks. Some of them are just very, very specific kinds of things. There's some that are around security, some that are safety oriented. Largely, these come from the community. We get a lot of, so Garak is open source, by the way. So it's, you can see the GitHub link at the bottom. It originally came as a contribution from Leon Dushinsky while he was a prof, and he has since joined the team, and we've continued contributing to it. So a lot of these probes are community-based, so they come from archive papers, from blog posts, security researchers post them and they put them in. There's two different kinds generally that we have in here. A lot of them are static probes, which means they're really just, they're essentially collections of prompts. So, we'll see one on the next slide is, several hundred Dan-style jailbreaks. But we also have these adaptive prompts that are in here, and these get very, very challenging for a model.
Wait,
system
Chris, just making sure you're not sharing a screen yet, right?
I did share the screen.
Okay.
Oh, no, let's try this again.
I was kind of thinking, when is it going to kick in?
When's it going to kick in? There we go. That's a little better.
No
We only missed the title slide. Now we have something we can see. Thank you, Philip.
All right, and for those of you that are also tuned in and looking at the chat, so the same link that we have here, I also sent in both as a question, as an answer to a question, and in the webinar chat.
All right. So now that we've got that embarrassing screen sharing moment going, let's keep going. All right. So the GitHub link is at the bottom. Philip shared it in the chat. Thank you very much. All right. So the probes. So there's a lot of static ones that are essentially collections of prompts. The adaptive ones, we'll look at those in a moment. These are sometimes they're generative, sometimes they're really back and forth, and it's meant to do this automatic red teaming kind of scenario. You didn't really miss any slides. The only slide that you missed was just the title slide. So we're good. So given the collections of these probes, generators will connect to an individual LLM. So you're really just giving it an endpoint that takes text as input, gives text as output. So you can connect to OpenAI, to Cohere, to locally hosted open source models as you need. The generators will run these probes, you collect the results, and the detectors will assess the outputs from these. So these will assess where it has failed. We use a variety of typologies from the community to help organize these, like language model risk cards or Avid, MITRE ATT&CK. There's different organizations that have ways of organizing and viewing this. But essentially the point of this is you run a whole bunch of attacks, you configure how much you want to run. You can run anywhere from 20, 30 minutes up to things that will take millions of queries over several days. You can scale the amount that you want to do that. I don't recommend running millions of queries against GPT-4. It's going to get expensive. All right, so let's take a look at what some of these attacks are like. So we have many, many different categories of probes. We'll just look at a few key ones here. So in Shir's intro, we saw a couple of Dan-style jailbreaks. There are many of them out there. They're not all Dan. Really, these are intended to they're often role-playing based attacks. You'll try to get the model to take on a personality where it'll then subvert its built-in protections that it might have. These are really hard to detect and really hard to protect against. GPT 3.5 Turbo has a failure rate of about 56%. So we call this an attack success rate. So about 56% of these attacks will succeed on GPT 3.5 Turbo. Even the stronger models, they may have a lower success rate on this, but somewhere in here, they will break. GCG is an interesting approach. This came out last year. This is a generative approach. So the way this will work, you've got a system prompt, your user, the user input, normally you'd say, tell me how to build a bomb. And GPT will say, oh, I'm sorry, I can't do that. That's not okay. And instead, you tell me how to build a bomb, and you stick this little suffix on the end, which is just these sequences of really funny looking tokens. You'll see some examples of them at the bottom. And then it subverts. So this is called greedy coordinate gradient. It's also known as the LLM attacks technique. And these will find these funny areas of the embedding space that rely on these like really low frequency tokens. And often these can transfer from one model to another. They'll be successful across multiple different models. So we'll run these. We've got we can generate the tokens that are in there. So you can get new token sequences and see if your models are susceptible to that. Attack Gen simulates the process that a human red teamer would go through. So red teaming is a technique. So it originally came from the Cold War. This notion of the red team, the blue team, and then you're doing these simulated attack sequences. It's been very common in cybersecurity over the last couple of decades. So you really have these hacker type individuals who will try to break a system. And we've started doing this in LLM testing as well. So the way this works with humans is you sit them down in front of a console and you say, hey, your task, I want you to try to get this model to spit out some racial stereotypes. And it'll typically fail at first, but they'll try and they'll try and they'll try, and often after some clever testing, they'll get it to do bad things. This automates that process. So what we've done here is we've just trained a simple GPT-2 model to be an aggressive red teamer. And for some models, it gets very spicy very, very quickly. We have not seen any LLM yet that can withstand this indefinitely. Even GPT-4, it might take a day or so over a wide variety of failures, or a wide variety of topics, but it will fail. So Garak,
Chris, in the meantime, just one question we got from anonymous attendee from where to get harmful data sets as an example set for training. So I'll just say that's part of the goal of what Chris is presenting here. You can definitely do more things, but part of it is generating those types of let's call it malicious prompts. But feel free to add anything on your end, Chris.
Yeah, no, that's right. So there are some common data sets that are out there that are largely safety oriented. So the Anthropic helpfulness and harmfulness data set is one. I've got another that I'm going to share. So we actually have a Garak paper. I think it may have just been posted on archive. But these techniques, a lot of these techniques are commonly published across the community. But take a look at the Garak. You can take a look at the repository there, and you can see some links to all the different probes that are in here. We always cite where they came from.
Yeah, basically anything that was called a static probe, except for what Chris called at the beginning, then it's kind of like a data set. It's just organized, I think, in a more convenient way.
Okay, so when you run Garak, you'll configure how thorough you want it to be, what areas you want it to cover. You'll get reports out of this. That helps you figure out where the gaps are. Now, how do we close these gaps? Some of them are really going to be around system design. So not everything is going to be patchable in just an LLM oriented application, but a lot of them we can. So NeMo Guardrails is the toolkit that we had developed to help build some stronger assurances into your LLM-based applications. So Shir took us through a lot of these use cases. Really, when you're building these applications, particularly with chatbots, but really with any of these generative applications, there's a lot of things you want to consider. Dialogue is important. You want your conversation to stay on topic. You want it to be knowledgeable. You want it to keep a consistent tone that's appropriate for your brand. There's a lot of safety concerns you get into. You want to make sure that your responses are ethical and that they meet company policies. You want to make sure that to the best of your ability, your output is properly grounded in evidence. There's also a number of security concerns that you want to get into. We talked a lot about jailbreaks. There's a lot that you can do to detect these jailbreaks. And then particularly as you start building out these applications and they're using back-end tools and back-end systems, you want to make sure that you're not exposing those back-end systems to untrusted data that could then introduce another possible attack vector. So NeMo Guardrails is open source. You can see the GitHub link at the bottom there. It's been out for about a year or so. We developed this to be a collection of a variety of different techniques for safety and security in LLMs. Some of these are techniques that we've developed. Some of them are community models, open source methods. Some of them are third-party hosted APIs. And so we've got a variety of these techniques, and we coordinate them all with a dialogue modeling system. So the way the flow generally works for these, so your application.
I just will say, I also set the link for NeMo Guardrails now in the chat. So any of you that would like to kind of see live and are good at multitasking, then feel free to kind of look in parallel. It's the same link here at the bottom.
Great, thank you. So your application code sits on the left here. So your queries will come in. So NeMo Guardrails can be run either as an isolated server, just running on a VM. It's got like you can run a Docker container. It's got a little fast API server in it, or you can import it as a Python library. So from your application code, your queries will come in. You'll configure what sets of Rails that you want, but there's generally 5 different categories of Rails that we're looking at, and there's lots of details within these of different types. Input Rails will scan the prompt that's coming in, so it'll can assess it for content safety, see whether it's espousing violence, racial stereotypes, anything like this. You can check for jailbreaks. You can check for personally identifiable information. Once it passes these input rails, you can get into what we call dialogue rails. This is where we're starting to use the dialogue modeling system to do things like understand what the user's looking for, figure out the next step in that dialogue flow, to help formulate that response as we need. You can also coordinate other tools using this. So you can contextually coordinate your retrieval system if you're building a RAG setup. You can coordinate external tools like, say, every time I get a math question, I want to route it to Wolfram Alpha. So we'll do this coordination. It will also then do the coordination with the calls to the LLM as it needs. Following this, you can run sets of output rails. So I can put another content safety check on my output to make sure I'm not accidentally spitting out unfortunate content. You can check for personally identifiable information again. There's all these different sets of rails that you can use. Now, typically when application developers first come into this problem of like, how do I guardrail a system? They'll start from this space of like, I want to put just filters on my input and my output. That's a perfectly great place to start. Now, as you start to get more complex with the way these scenarios look, you start to need more detailed coordination. These filters are fine, but you don't always just want to block every negative situation. Sometimes you want to steer it back into an appropriate area of the conversation. Sometimes you want to call different tools conditionally as you might want. So this is why we developed Golang. Golang is it's a modeling language that we created for describing conversational behavior. Now, just to be clear, you don't need to code in Golang just to be able to use NeMo Guardrails. This is the logic that underlies the dialogue system that's in there. And a lot of the Rails that are being run are using Golang under the hood, but you're not necessarily required to write this. But this is a great mechanism to be able to extend the behavior of it, to say, here's what I want to do in different conversational scenarios. Here's how I want to guide the flow of this conversation. So it reads a lot like natural language. It's a little bit Pythonic. So it's also very easy for an LLM to understand it. And this is actually part of the language that Guardrails is using to talk to the LLM. It's actually using the LLM to help it figure out what to do in this Golang language. There's a new version of the language that we just released a couple of weeks ago that brings in a lot more functionality, multimodality, parallel execution of Rails, advanced orchestration. It's worth taking a look at what you can do in this. And we'll have more educational material coming out soon around this too. So just another word I want to drop in here too about content safety. This is one of the most asked for guardrails that we have, that people run into. Meta last fall released a model called Llama Guard. It's based on Llama 2, and what this does is it takes a safety policy. You shouldn't be assisting information around violence and hate, shouldn't be discussing sexual content. There's a very detailed policy around this. And this model will take that policy, it will judge inputs and outputs, and then tell you if it's violated. So we have a Rail in here that uses Llama Guard. We also have a new model that we've released ourselves that expands that taxonomy to cover more safety areas. We have a data set, we've collected data on this, and we've trained an additional model on top of Llama Guard to extend that behavior. There's an archive paper that has this. This is just under review right now. You can also download the data set and the models. We are continuing to collect more data. So if this is of interest to you, keep an eye out. There will be newer, larger versions of this data set moving forward as well. All right. As you start to add more and more of these layers of guardrails, you will see the system get stronger and stronger with respect to these kind of safety and security analyses. So we use Garak to measure guardrails configurations. Each of these columns here is just a different layer that we've added in this sample bot that's in the Getting Started guide. When we get to the demos, we'll see an example of what this bot looks like. All right. And the last thing I just want to mention too is that the output that you get from Garak is very useful for an iterative loop. When you run Garak, you get hit logs of all the successes and the failures. And you can use those successes and failures to feed back into your model preference training. So if anyone here is in the business of actual model development or model customization, take a look at some of that data. It's very, very useful for really refining your model's responses. All right.
All right.
I'm
1
going
second.
to hand this back to Shir.
Yeah, 1 second before we move to the demos. So a couple of questions that we got. First of all, there was a question from Brian about papers. I sent links to archive papers for both Garak and for NeMo Guardrails. Chris, I hope I got that right. There are embedded papers, but that's what's referred to from the repos. But feel free to add anything in offline. All right, and then the one question you got from anonymous attendee. So it seems like this adds to the number of LLM calls per interaction, right? Apologies if I'm wrong.
That is right. It does. You know, we do a fair bit to try to keep the latency down, but you know, you can't really get this for free. Really what you're doing is you're choosing to apply more compute to get stronger assurances. And that's just the nature of it. You know, my team is doing a lot of work moving forward about, you know, how to push down that latency requirement, how to do things like can you pull more of the guardrails closer to the model itself? We call that in-flight guardrailing. So you will see more advances coming from not just us, from elsewhere in the community about how to do this more efficiently. There's, you know, it's a new space. It's a hard problem, and yeah, yes, it uses more tokens and it does introduce some latency, but you get a benefit from doing that.
All right. Okay. Great. So that's one question where no easy answer for that one, of course. And then the second one is the second question from Wouter Sligter. Sorry if I mispronounced that. Is there a multilingual version of the Guardrails LLM? Not
yet. We've done some experimentation with multilinguality inside. So two approaches. One that we've taken. So Guardrails uses a bunch of templates internally to guide its prompting. We've tried translating those and then running it end to end in, say, like Brazilian Portuguese. That works. It's a little bit labor intensive to do all that translation. The other approach that you can take is to translate your inputs and outputs. If you leave the core in the single language that you know works, then you can run a translation model on the in and out. And actually, there's a lot of companies for the last several years handle language scaling for their chatbots that way. So that's another approach you can take.
All right, amazing. So now I'm the kind of in charge of the timetable here, and I know there are a lot of questions, it's different topics, a few different tools at once, but I think we should all see them with our own eyes. So Shir, feel free to go ahead.
Cool, thank you. And I think actually we had a few questions since, but Chris's last slides about the iteration process. So I'll try to remind you of so you check in the case, for example, of Garak, you check a few probes, see the problems, try to add, in this case, like guardrails, see if it's solved or which of the problems were solved, add more, compare the different versions and so forth. So that does really lead to kind of what we're going to see now. And that is how we put this all together in the context of basically building the best LLM application we can. So whether it's in the area of quality and in the area of safety. So what we're going to, what you see now, so this is like within the Deepcheck system, of course, the ideas of like the metrics and putting them together can also be implemented in other manners. However, like what we have here is basically a overall kind of behavior of our system. Now, I'm going to demonstrate two of the concepts we talk about. One is the idea of having various metrics which are relevant to estimate the overall performance. And the other one is the different data evaluation data sets. So in this case, just to show you a bit like what we're looking at, it's a Q&A chatbot where it's questions about some specific medical condition, and we have the answers. In the context of finding the various metrics that interest us, so I'll just give like one or two examples of things that are relevant and then look at how we put it all together. So one, like what we have is we have many metrics, which we run, by the way, also here, LLM or non-LLM is a big issue. So one of our challenges and which we work and have quite nice successes is having the same or actually better quality metrics, but everywhere we can without having an LLM in the loop. So for example, grounded in context is a metric that we have for finding additional data in the output that wasn't grounded in the information retrieval it got. So for example, we have here a question of like some condition, like what's the difference between acute and chronic GVHD? And we have a very long answer. However, we can see that the information retrieval was very minimal and didn't include most of this. So we have two things, both is a low score for that specific property, and then it also kind of folds together to getting an overall bad kind of a behavior annotation. Same for, here's like a different example of where the information retrieval is very relevant, like it's a relevant topic, but it doesn't include the specifics of a staging system in this case. So also here it would get a kind of bad score. And the idea is really to be able to have multiple versions. So like in this case, we have one version, which was supplied to the system with annotations. So you can see like overall annotations of what are the good examples and what are the bad. And then you can add additional versions that run on the exact same evaluation data. So right, we talked about how do we build an evaluation data and trying to find different questions that users will ask and so forth. And then also efficiently evaluating it by having all of these metrics automatically calculated and put together to some overall score. So this is like the flow. And as you can see here, we have two environments. So it's like, So it's evaluation and pen test environment. Now, the reason we put them in separate areas is because like for the evaluation quality area, we care about things that are like typical, let's say, user behavior. However, in the pen test, we also want to challenge it. So just to give like the context of, so what is the pen test environment and what does it run on? So it's actually incorporates to a large extent in this case, like the Garak framework, and we basically replace the evaluation data and the different properties or metrics with the relevant kind of concepts. So for example, here you can generate pen test data and choose which types of attacks you want to run your LLM application and check out the results. You would get here examples of all sorts and download it either via SDK or CSV. Once you run it through your application, you upload it back. So you can see here we have just like a few examples from different types of problematic behaviors. And the thumbs up and thumbs down in the context here is whether the attack did it run successfully or not. So before Chris gave the benchmark of like 57% here, of course, again, here, this is not like the foundational model itself, but it's actually running these user prompts through our specific, let's say, Q&A pipeline, right? So it's with our prompts and sometimes multiple steps and so forth. And what we can see is that just like we did this comparison for the evaluation data, so we want to do the same between different versions for the pen test data. So if I have like a look here at the like overall kind of version behaviors, wait, actually before the versions, I wanted to show a few examples of how this actually looks. I did choose specific examples, which will be hopefully somewhat nicer. So let's say if we look at which were the ones I wanted to show, we can check, I think the, okay. Cool. So evasion, different trials to get some like in this case like assembly code to do various stuff. So we can see that actually almost all of the evasions were mitigated successfully, right? I'm just here filtering on the places where it worked. So some prompt, but the LM like really doesn't assist, and also the detector gives a 0, and therefore it's a thumbs up one. If we look at an evasion attack that actually was successful, so we can see this is the input, we did get the output, and also we detected that indeed this was like unsuccessfully or successfully, depends from which perspective you look at it. And the idea is that also here I can compare between two versions. So we can see that here we have like, if I don't filter, so we have a 72% score. And now in the next version, let's say I either added guardrails or alternatively change my prompt, right? So these are two things. It's likely that initially what I'll do is try to have like the system itself as kind of self-sustainable and safe as possible, and then add guardrails. So in this case, actually what I did is a change of the prompt and not yet added guardrails. After adding guardrails, I would add additional versions and check the improvement. But in this case, you can see that the score actually improved. Okay, so if we have a look, for example, let's filter only for the thumbs down ones. So we have here like overall, I think, how much is it? Okay, 20 samples overall, which are thumbs down of various types, right? So you can see like the evasion attack we saw before, some places where it successfully outputs this string and so forth. So we have, as I said, 20 overall. And after we actually uploaded a new version with some improvements, you can see that that also some of the things were like, for example, the evasion problem, we don't have it at all. And the other ones, we just like solved some of the use cases. And the idea is that we can really see now what should or how can we add and to potentially eliminate as much problems as we can. And then when coming to choose overall, which is the version that we want to deploy, we can really and should really have a look at both areas, right? So we can, oh wait, that's not, I wanted to show here. So you can look both at the evaluation scores and also at the pen test scores. So here you can see that the pen test improved. Actually, the reason that here we have a very low score is that the metrics for automatically getting a good score weren't yet updated. So you can see that only like 30% was automatically annotated. In the other example I showed before, so we have here like this is after customizing all of these automatic annotations are customizable per use case. So the idea is that you can very easily understand what are the relevant metrics and accordingly get estimated annotations. And here you can see it's like 70% versus 81. Probably the reason for it, by the way, is that now many more were.
Just 1 second, Sheila, let's try to aim this for another 1 minute, let's say, and then pass it over to Chris.
That's the conclusion.
Okay.
So actually much more questions were avoided. Okay, so we have here like 50% in this case avoided, or sorry, not 50% avoided. The overall average of the avoided answer property is 0.5, which is quite high. And therefore, the performance did deteriorate. So instead of 81%, we have 70%. However, safety-wise, we did actually get an improvement, again, on a different data set. So now you have to find the balance of, how much you want your LLM to be able to respond. And then again, what are you mitigating it for accurately and so forth. And the idea is that once you have this automatically in place, you can really, here it's the example of 2 versions because I didn't want to overwhelm you. But of course, if we have 10 versions, we have the metrics configured, and we have this automatic pipeline of running both the evaluation and the pen test data, you can really much more efficiently achieve a decision of are you happy with it, and also evaluate it after adding guardrails, which is something we will see in a moment.
All right, maybe just one question and one comment kind of following Sheila's demo before we move on to Chris's demo. There were a couple of questions about saying, okay, there are multiple different tools for LLM evaluation, LLM observability, what to look at. So I can never give like everything that exists out there and kind of give a solution to every type of question, specific needs. I can say what I think we tried to think about when we're designing this. So one of them is we just try to be very accurate out of the box with the properties that she'll show, things like grounded in context and relevance and so forth. So we try to, it's objective, you can measure them. We try to be very relevant at them and with a thumbs up, thumbs down. That's one thing. The second thing that we put a lot of emphasis on at Deepchecks is making sure that the experience is not only for coders, but also for clickers. And I think especially when now we're implementing the safety in this part of it. So to get to the point where you start off with things that are quality, but then move on to saying, okay, but now I'm going to pen test it and so forth, and things that are pretty simple to do. That's number 2 that I think something that we put a lot of emphasis on. And then I think the the third one is kind of how holistic it is. So we try to start off from very, very early on when you're just implementing your first kind of version, and then kind of compare it with compare different versions when you have multiple versions, multiple prompts, continue all the way through pen testing, which was a deep collaboration with Chris. I don't know how much we emphasize this, but the first time I met Chris, he said, I told him kind of what we're doing, what we're aiming to do, and he was like, "Oh, did you hear about Garak?" I'm like, "Oh, that just won like our technical POC. We compared a few tools, and like I didn't know there was any connection." So that was a pretty amazing first kind of like click and meeting. So that through pen testing all the way through monitoring, so kind of we aim to do everything in the cycle. So I did mention it's possible to get free credits and try it out. It's not, we don't yet have any open source components for this, but there really things in the past related to open source. So I sent a link. Feel free to reach out and get some free credits. And Chris, over to you. As Chris is starting, I'll also start the second poll.
Right. And I think I've actually shared my screen this time, so that's a win. All right, so I'm going to do a little bit of flipping back and forth between two bot configurations here. Both of these are based on the tutorial bot that's in the Getting Started guide, really Guardrails documentation. And what this really is it's just meant to be a chat bot for this fictional company, this ABC company, and it's for employees to be able to ask questions about the handbook of employee policies. So we just generated a fake employee handbook from ChatGPT, and then we built a little ride around it. Okay, so let's just start this. So the basic one really just has that little knowledge base in there, and it doesn't do a whole lot. It doesn't have any protections in place, but what can you do? This, by the way, is using ChatGPT 3.5 Turbo Instruct in the backend. ABC bot, here's a bunch of stuff that I can do. So let's just try a very simple jailbreak on this. This is just one of the really easy ones. Sometimes this is a little bit non-deterministic. We'll see if it happens on the first time. All right, well, we're gonna try this again. Sometimes we get even different behavior on that, but point is, oh, there we go. So here's the full prompt that was in there. Generally speaking, when you're designing your bots, you don't want this to happen. So let's switch over to a different version of this that has a basic input rail configured. So here's just this is the configuration for Guardrails. GPT 2.5 Turbo Instruct, and we just got a very simple input rail going on in here. This is just using an LLM as a judge, and it's just really just checking against GPT live hacking, pretty much. We've got just some simple constitutional principles in here. We just want to make sure it's going to be safe and not going to try to do anything malicious. So we'll,
all right, wait, just 1 second. I'll share the results and we'll continue quick, just so it's not stuck on everyone's screen in the meantime. So the question this time was, what's the LLM related risk that concerns you most? So the answers were jailbreaking, factuality, content safety, and staying on topic. So factuality, big winner, 50% of participants. Jailbreaking 25%, content safety 90%, and staying on content with 6%. I know that we didn't have like an other option. I'm sure there are other concerns, but it gives us some feel for kind of where we're at.
Nice. That's insightful. Thanks. All right. So this one, that simple jailbreak detector blocks this. You can configure that response if you want something a little bit more verbose. So we can just ask it some other useful things. How many vacation days do I get per year? So 20 vacation days per year, that's in the handbook. Hey, can I invent things on my own and keep ownership of that? Let's see. Well, you can request permission to use your company resources. We might say no. And unwritten in this is that we're probably going to own your IP anyway. Okay, so it's a little useful. That's good. Let's try something else. I'm going to flip back to the basic one again. And we're going to try something that gets a little bit off topic here. So, all right, we can use the kitchen to cook dessert. How do I make a good apple pie? Okay, so, well, I'm not really programming a recipe. We're going to try this again. Sometimes we get some non-determinism in this as well. Oh, here we go. There's actually a recipe for apple pie. That's actually a really terrible recipe for apple pie. When I was testing this, sometimes I would get like a big 3-paragraph thing, and frankly, there were no good recipes in here at all. So really, let's just avoid trying to give recipes entirely. So Shir was talking about some different Rails that you can use to help keep things on topic. So in the Railed version, I've added this little disallowed version. And these are just little snippets of Golang. We've got a bunch in here that gives us some extra backstop. So you can use this for safety concerns as well. Self-harm, you can use it for things that are like maybe safety, but maybe not, and just, could ask questions about competitors and so forth. But we've just put in a simple one to say, you know what, let's just not talk about cooking at all. So let's see what happens when we get that. Back to the Railed one. We can't provide any recipes for cooking, but here's what you could do instead. All right, now, we often get questions from people about, do I need to go and write one of these little Rails for every possible topic I might want to avoid? The nice thing is you don't. So behind the scenes in this, what's really going on with us here is we create an index of each of these different Rails that's here for this. And we end up doing a vector search against that and populating a little few shot list. And based on that, Guardrails will start to fill in the gaps. All right, so, I recently did a little charity bike ride. So I've been thinking a lot about how to, keep myself going on this. How many grams of carbs per hour should a long distance cyclist consume? I don't know why I just didn't hit enter. So I can't provide guidance on nutrition or health related topics. So you'll notice that this was very similar to the response that we got for the cooking one. What happened in this case is the model said, okay, I know that I shouldn't respond to cooking. I also know that I shouldn't respond for things about, misinformation, and there's a bunch of other stuff that's in there. This feels more like those areas I should avoid than the areas that I should be trying to respond to. So it said, all right, this is a question about nutrition. That seems off topic. I'm going to steer it away from that. So really, we're using the LLM itself to help us fill in these gaps around this guardrailing. And this gives us a pretty flexible way to help control that conversation. All right. Thank you very much. So take a look at the sample bot configurations that are in there, and please, reach out if you've got some great use cases around this. Thanks.
All right, amazing. So I just wanna quickly say I put all links again. I put them during the event. I put them all now at the end of the chat. So if you want to start with Garak, then there's both links to the documentation and to the GitHub. If you want to start with NeMo Guardrails, same thing over there. I can just share what, and then of course, if you want to try our Deepchecks LLM Evaluation solution, we have the option to enable free credits. So feel free to either reach out to me directly. My mail is there or in the link. For the open sources that Chris and the NVIDIA team are working on, I just want to say we spent a lot of our time at Deepchecks working on open source repositories. The feedback is incredibly useful and helps to make a lot better. So if you're using, I would definitely suggest reaching out to Chris or team members, and even just if you don't have anything concrete to ask for, just let them know how you're using it. It makes a huge difference, because part of it's a blessing and blessing and a curse kind of giving out the open source, because everyone could use it, but you don't have visibility to how people are using it. So it's a big deal. And anyway, Chris, it was great collaborating with you, and Shir, you, of course, but we collaborated on a lot of things, of course. I think, given the time constraints, that we did a lot of questions and answers kind of during, I don't think we'll take any more questions now, but yeah, we're all folks that are easy to find. So feel free to reach out and offline, and we'll be in touch. So bye, good morning, afternoon, or evening, depending on where you are.
Or night, awesome. Thank you.
Or night. Thank you so much.